In this video, we're going to finish off the topic of factorization, and some of the questions, actually, other methods would be easier to solve them. So I'll introduce using the formula in this video as well. And I remember in the last video, I just sort of solved problems randomly, so we'll go over some of the problems I skipped as well. So I want to start with the last question because I think it's the most interesting one. It says solve for this equation. So we have x squared minus 11x plus 29 to the power 6x squared plus x minus 2 is equal to 1. So now you might be thinking, what if I take the logarithm? And that is a valid way to approach this question. But if you take the logarithm, there is a special case you need to consider. So it's very easy to miss that case. So here's how I like to think about this question. So if I have any base, if my base is 1, regardless of what power I raise it to, I'm always going to get 1, right? So I will first of all let my base be equal to 1. And 1 raised to any power is always going to give me 1. So if my base is 1, then I solve the quadratic equation x squared minus 11x plus 29 is equal to 1. X squared minus 11x plus 28. So if I subtract 1 from both sides, is equal to 0. So therefore, now I can use the sum and product method. The sum is the middle term, is negative 11. The product is 1 times 28, so 28. So what two numbers, when I multiply together, I get 28, and when I add them together, I get 11. And I think the numbers are negative 7 and negative 4, right? So minus 7 minus 4 gives me minus 11, and their product is 28. So I have x squared, or 1x squared, minus 7x minus 4x plus 28 is equal to 0. Now I can factor out the x from my first two terms. So I have x minus 7, and I also want to have x minus 7 for my second two terms. So what number do I have to factor out? Well, if I factor out the negative 4, then negative 4 times x is negative 4x, negative 4 times negative 7 is negative 28. So now I can factor out a negative x, I can factor out x minus 7 and x minus 4. And therefore, when you solve this, you get x is equal to 7 and x is equal to 4. So you set the first term to be 0 and the second term to be 0. So these are two solutions, but we're not done yet. We have just discussed two solutions. Another possibility is, what if I have any base, I raise it to the 0 power? Well, that is always 1 as well. So I need to solve the power is equal to 0. And solving this, so any base raised to 0 is going to give me 1. So leveraging that information, I can solve the exponent equal to 0. And now when I solve this equation, the sum is going to be 1. The product is going to be 6 times negative 2, that is negative 12. So the two possible numbers, I believe, is 4 and negative 3. So 6x squared plus 4x minus 3x minus 2 is equal to 0. And from the first two terms, I can factor out the 2 and an x. So 2x, I will have 3x plus 2. And I want to factor out 3x plus 2 from the second term as well. So what number do I have to factor out? Well, if I factor out a negative 1, then I get 3x plus 2 for my second term as well. All right, so now I can factor out 3x plus 2, and then I can factor out 2x minus 1. And now if I solve this, if I let 2x minus 1 equal to 0, x is equal to 1 over 2. And if I let 3x plus 2 equal to 0, x is equal to negative 2 over 3. So now we have four solutions. We have 1 over 2, negative 2 over 3. We have x is equal to 4 and x is equal to 7. Now something you might want to avoid is that 0 raised to 0. Now in some cases, for example, maybe in programming, this is undefined. In combinatorics, it might be useful to define it as 1, but we want to avoid 0 raised to 0. So in analysis, that would be an indeterminate form. So when my exponent is 0, I want to make sure that the base is not 0. And when does that happen? When we have distinct roots. So 7 and 4 is distinct from negative 2 over 3 and 1 over 2. So I don't have to worry about having 0 to the power 0. So we have considered two cases. Now the final trick case that you may overlook is that what if my base could also be -1? And -1 raised to an even power still gives me +1. So let me solve for my base is equal to -1. So my base is x squared minus 11x plus 29. And I'm solving it for -1. So x squared minus 11x plus 30 is equal to 0. The sum is -11. The product is equal to 30. And I think the two numbers will be -6 and -5, right? So x squared minus 6x minus 5x plus 30 is equal to 0. I can factor out an x, so x minus 6, and I want x minus 6 for my second two terms as well. So I can factor out a -5. So minus 5 times x is minus 5x, and minus 5 times 6 is plus 30. So now I have x minus 6 and x minus 5. Now, you may be thinking, well, I have two solutions. X is equal to 6 and x is equal to 5. But this does not guarantee that our exponent is even, because for our third case, we have two conditions. The base is -1, and whatever the exponent must be even. So now let's go to our exponent. This is our exponent. When we substitute 6 in it, so 6 times 6 squared plus 6 minus 2. So we evaluate this. 6 times 6 squared plus 6 minus 2. This is even. This is 220. So therefore, x is equal to 6 is a solution. But if we take x is equal to 5, 6 times 5 squared plus 5 minus 2, this is odd. This is 150. This evaluates to 153. So therefore, if it's 5, then I don't get an even exponent. So -1 to an odd exponent would still give me -1. So x might equal to 5, you reject that solution. So overall, you have 5 solutions. X is 7, x is 4, x is -2/3, x is 1/2, and x is 6. So those are your 5 solutions to question 7. All right, let's go to question 6. Question 6 says the area of the trapezium is this value. Find the value of x. So how do we solve this? Well, the area of a trapezium is the sum of parallel sides. So x minus 1 and x plus 3 are parallel sides. So it's x minus 1 plus x plus 3. So sum of parallel sides, and whatever that sum is, you want to multiply by the height. So height is x, and then you want to divide by 2. So 35.75 is equal to, now whatever my sum simplifies to x plus x gives me 2x, minus 1 plus 3 gives me plus 2. X divided by 2. Now if I multiply by 2 on both sides, so 35.75 times 2 is actually 71.5. And that is 2x squared plus 2x. So I just distribute the x. And I don't like having 0.5, so let me multiply by 2 again to remove that. So I get 143 is equal to 4x squared plus 4x. So I multiplied both sides by 2 because I don't want to work with 0.5s. And now finally I get 4x squared plus 4x. I subtract 143 from both sides, and that is 0. Now if I have ax squared plus bx plus c equals to 0, another way to solve this equation is that x is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. All right, so because of how this is set up, let's use this formula to solve for x. So that is using the quadratic formula, and we will in a future video learn how to derive this formula. But for now, let's just use it. So minus of my second coefficient, so minus 4 plus or minus the square root of 4 squared is 16 minus 4 times 4. So 4 times a is 4, 4ac, right? 4 times 4, and then c is negative 143. And that is minus 2288, negative 2288. Divided by 2 times 4 is 8. So now I can solve minus 4 So my square root, 16 minus of minus 2288, is 2304, and the square root of that number is just 48. So I have minus 4 plus or minus 48 divided by 8. And remember, x is a height. We can't have a negative height. So we want positive answers only. So the answer would be 44 minus 4 plus 48 divided by 8. So you reject the negative solution. And that is 22 by 4. And I believe that is 11 by 2, which is just 5.5. So 5.5, which is the height, is your answer. So 5.5 centimeters should be your answer to question 6. So 5.5, yes. So that is the value of x. And now for 1 and 2, we covered most questions, so I won't discuss that. And I remember I also finished for part F for you. So let's look at something else. So let's solve E. E says x squared plus 2x minus 14 to the power of 5 is equal to 1. So what base raised to the 5th power gives me 1? Well, the only possible answer in this case, because 5 is odd, is positive 1. So x squared plus 2x minus 14 has to be equal to positive 1. And x squared plus 2x minus 15 is equal to 0. Now, let me just factorize this very quickly, but feel free to use the sum and product and find the two numbers. But I think it's plus 5 minus 3. That should be the factorization. And this tells me that x is equal to 3 or x is equal to negative 5. So that should be the answer to 4E. So I may not factorize properly. I may not use the sum and product method. I'll just prefer to do it in my head because I think I've done enough examples for you to get familiar to how to do it. But if not, feel free to play the 2 videos and then get some hands-on practice with factorizing. All right. 3, let's do D. So we have 3 raised to, well, let's think about it. 3 raised to what power gives me 1 over 9? 1 over 9 is just 3 to the power negative 2. So if the bases are equal, the exponents must be equal. So actually what I'm trying to do is just solve for 2x squared plus 9x plus 2 is equal to negative 2. Or 2x plus 9x plus 4 is equal to 0. And therefore, x is just minus 9 plus or minus square root of 81. So, or let's factorize actually. Let's not use the formula. So sum is 9, product is 4 2s are 8. So what two numbers do you think? I think it's just 8 and 1. So 2x squared plus 8x plus x plus 4 is equal to 0. And if I factor out to 2x, I get x plus 4. From the first term, I can factor out to 2x. So I'll get x plus 4. And then from the second term, I also want for x plus 4. So I have to factor out a positive 1. So therefore, I get x plus 4 times 2x plus 1 equals to 0. And this gives me 2 solutions, which is x is negative 4 and x is negative 1 over 2. So please feel free to do it a bit more slow. But I'm just trying to give you the idea and the solution on how to go on about this. I think my stylus disconnected. So let me just quickly find my charger to connect the stylus back. But the answer is negative 4 and negative 1 over 2. So that is the correct answer for this question. All right. So we are done with D as well. So what about C? Well, 2 raised to the what power gives you 8? Well, that is 3. So you just want to solve for x squared minus 4x plus 6. So 8 is 2 to the power 3. So you just want to solve for x squared minus 4x plus 6 is equal to 3. 4 to the power, what power gives you 1? Well, 0, right? 4 to the 0th power gives you 1. So that is just what they're asking. And it's the same for 4a as well. So I think you are very capable of solving these questions on your own. So let me just leave these for you to do. And finally, let's see. I believe I did do question 1.3c in the previous video. So let's just pick two questions at random. Maybe question F and question... Yeah, let's start with question F. So 2x squared plus 9x minus 5 divided by x to the power 4 plus 1 equals to 0. When is a fraction 0? Well, when the numerator is 0. 0 divided by anything is equal to 0, right? So we want to solve for 2x squared plus 9x minus 5 is equal to 0. And we don't have to worry in this question because our denominator is always positive. It's always bigger than 1, actually. So we don't really have anything to worry about. We just can focus on solving this equation. So the sum is equal to 9. The product is equal to negative 10. So the two numbers would be, I believe, 10 and negative 1, right? So 2x squared plus 10x minus 5 is equal to 0. And we can factor out x plus 5 from the first two terms. We can factor out 2x from the first two terms. So we get x plus 5, and we can factor out in negative 1 so that we get x plus 5 in the second two terms as well. And so this simplifies to x plus 5 and 2x minus 1. And therefore you get x is equal to negative 5 or x is equal to half. So those are going to be your solutions to question 3F. All right. So let's do question 3E. So question 3E is very similar. It says 6x squared plus x minus 2 is equal to 0 divided by x squared plus 7x plus 4. Now because we want to avoid the 0 divided by 0 form, so we need to check for both the numerator and the denominator. So let's factorize 6x squared plus x minus 2. So let's solve for this equal to 0. So the sum, the product is negative 12. The sum is equal to 1. So I believe the two numbers would be 4 and negative 3. So 6x squared plus 4x minus 3x minus 2 is equal to 0. I can factor out a 2x from the first two terms. So I will get 3x plus 2. And I can factor out a negative 1. So I get 3x plus 2 from the second two terms as well. So I have 3x plus 2 and 2x minus 1 equal to 0. And therefore, my solutions are x is equal to 1/2 and x is equal to negative 2 over 3. So just put them individually to be 0 and you will get these two solutions. But you need to check for the denominator as well. So if you use the sum and product method, I believe you should get x squared. So I believe this does not have any real roots, and there is a possible way to check this. So that would be x plus 3. So if I have to express it as by completing the square, then I think I would get something like this. 7 by 2. So that would be 7x plus 49 by 4. 49 by 4. So I would have to subtract something, I believe. So let's use the quadratic formula to find the root, because I think it's difficult to factorize this one. We need two numbers that has a sum of 7 and a product of 4. So if you look at something called the discriminant, so the discriminant is just 4b squared minus 4ac, so which is the middle term, 7 squared, 49, minus 4 times 1 times 4. So it has two roots. So we see that because the discriminant is bigger than 0, so we have two complete roots. So we can solve for this equation. So let's use the quadratic formula. Minus 7 plus or minus the square root of b squared, which is 49, minus 4ac, so 4 times 1, which is 16, all over 2a. So 49 minus 16, that is 33. And basically, we're going to get an irrational root, I think, because square root of 33, I believe, is irrational. So we don't have to worry about getting a 0 over 0 form. So our solutions would be these two values. All right. But usually you want to be careful so that you avoid not getting 0 by 0. So and I believe the rest of the question is pretty much done in the same way. So for B, again, your denominator is always bigger than 0. So you just need to set your numerator to be 0 and solve the question. So for the last question, let's just do A. So we have 3x squared plus x minus 10 divided by x squared minus 7x plus 6. And therefore, if I set the numerator to be 0, then the sum is 1, the product is negative 30. And what two numbers might that be? Well, I think that is 6 and negative 5. So when I add them together, I get positive 1. The product is negative 30. The 3x squared plus 6x minus 5x minus 10 is equal to 0. I can factor out the 3x from the first two terms, so I get x plus 2. And I can factor out the minus 5 from the second two terms, and I get x plus 2 again. So you want to factor out from the first two terms and the second two terms. I factor out the 3x from the first two terms, I get 3x times x plus 2. I factor out the negative 5 from my second two terms, I get minus 5 times x plus 2. And now I can factor out x plus 2. 3x minus 5 equals to 0. So therefore, x is equal to negative 2 and x is equal to 5 divided by 3. So those should be my two solutions. And let's just check our denominator. So using the quadratic formula, our denominator is 7 plus or minus the square root of 49 minus 4 times 6. 4 is a 24. All over 2 times 1 is 2. So that is 7 plus or minus 49 minus 24. So that is 25. So plus or minus 5 divided by 2. So therefore, we get the solution x is equal to, so we're looking at the denominator here, x is equal to 6 or x is equal to 1. And if we look at the x values, these are completely different. So I don't have to worry about getting a 0 by 0 form. Whenever my denominator is, so these actually are not in the domain of the function. So if you think about it, usually we should express x is not equal to 6 and x is not equal to 1. So that is our restriction. If x is taking on these two values, our denominator will be 0, our fraction is undefined. So our x's can take these values in the numerator to give us 0. So this is the answer. Your x cannot be these, otherwise your denominator would be 0 and then it would be not be possible to calculate. So I believe that is about it for this topic and we'll be moving on.